In this interesting video, we'll be looking at 10 questions to master circular motion. Watch this video to the end and you will see how easy circular motion is once you master the following 10 calculations. It covers everything you need to know under circular motion to pass your JAMB CBT, your WAEC CBT, or any exam, any physics exam you're preparing for. Please watch this video to the end. A particle of mass 10 raised to the power minus 2 kg is fixed to the tip of a fan blade which rotates with angular velocity of 100 rad per second. If the radius of the blade is 0.2 meters, the centripetal force is... So let's pick out solution. That is the first thing to do. Then given mass, M is given as 10 raised to power minus 2. Remember, if you convert it, that will be 1 over 100, which is 0.01 kg. The next value given is the angular velocity. Remember, omega, this is angular velocity. It's given as 100 rad per second. Identifying these parameters is the first success to solving the calculation. The radius, R, is given as 0.2 meters. Now, what are we looking for? The centripetal force, F. That is the question. So, let's derive. Remember that centripetal force F is equal to mv squared over r. In this case, V is not given, but there is a relationship between V and omega. So when you write mass as mass, velocity is the same thing as r omega. You square it. I've ended up writing this velocity as r omega. They are equal. Now divide by r. This will give us another formula for centripetal force. R will cancel one r, so that you will have F to be equal to m r omega square, or m omega square r. Please note this other formula for force. And I know you know the formula also, that force is equal to ma. Please note these formulas for centripetal force. It depends on what you are given, where acceleration is v squared over r. So whichever one you're given will tell you the one to use. So we are going to use this one. If you like, you can find omega, make omega the subject of the formula and put it in this question. But let's apply this direct. So we are going to use F is equal to m omega square r. This is another formula for centripetal force, where m is 0.01 times the omega is given as 100 times, remember, omega squared times r, which is given as 0.2. You see how easy this is. Once you know all the parameters you're given, you will find it very easy to solve questions on circular motion. So the final answer will be 20 Newton. Question 4. A stone is tied to a string. A stone tied to a string is made to revolve in a horizontal circle of radius 4 meters with an angular speed of 2 rad per second. With what tangential velocity will the stone move off the circle if the string cuts? So we are looking for tangential velocity V. The first thing to do is to write out all the parameters given. The first thing to identify is R. That's 4 meters. Speed. This is angular speed. Angular speed 2 rad per seconds. So we are looking for tangential velocity V is the question. So using the formula, V is equal to R omega. R is 4, omega is 2. So that the final answer will be 8. Then you put the unit meter per seconds. Question number 5. An object of mass 0.40 kg attached to the end of a string is held round a circle of radius 2 meters with a constant speed of 8 meters per second. Calculate the angular velocity of the object. Okay, solution. Write out everything. Take your time. Carefully write out everything. The mass is giving us 0.40 kg. Radius is giving us 2.0 meters. Speed is giving us 8 meters per second. Calculate the angular velocity. Omega is what we are looking for. The next step after writing everything you're giving is write the formula using V is equal to R omega. Make omega the subject of the formula. Divide both sides by the one you don't want, so that once it cancels out, the one you want will stand out. Omega will be V over R. Then you substitute 8 over 2. Your final answer will be 4 rad per second. Please, if you observe, this mass was not used. Sometimes in some questions, you'll be given parameters that you don't need. You'll be given parameters that you don't need. Just ignore the ones you don't need. Use the ones that you need and solve the problem. Question 6. A man spins a mass of 5 kg in a vertical circle of radius 2.5 meters. Calculate the maximum and minimum tensions in the rope if the speed of the mass is 12 meters per second and G is given. So this one involves tension in the rope. Given mass is given as 5 kg. Radius is given as 2.5 meters. V is given as, that's the speed, is given as 12 meters per second. And G is given as 10 meters per second squared. Now, if we have a vertical circle, we center, and then this is the radius R, which is given as 2.5. The maximum tension in the rope, T, will be, remember, tension is a force. Tension is a type of force. Is going to be, the maximum will be F plus mg. And which force are we talking about? Since it's circular motion, it will be mv squared over r plus mg. Let's substitute to get it as the maximum tension. T maximum will be mass, which is 5, times V, which is 12 squared, all over the radius R is 2.5, plus the mass is 5, times G is 10. So this one will give us 288 plus 50. That will give us 338 Newton as the maximum force. For the minimum force, T minimum will be, the tension will be force minus mg. That will be forces mv squared over r minus mg. So let's substitute to get the minimum force. That will give us m is 5, v is 12 squared, all over r 2.5, minus mass is 5 times 10. So this one gave us 288 minus 50. That will give us 238 Newton. Remember to put the unit of tension is a force, is Newton. This is the minimum force. Question number 7. An aircraft of mass 10,000 kg is traveling at a constant speed of 200 meters per second in a horizontal circle of radius 15 meters. Calculate the centripetal force acting on the aircraft. So the first thing first, let's identify everything. It will help you to remember the formula. Mass m given as 10, speed 200 meters per second, radius r is given as 15. Calculate the centripetal force F. So answer, which formula are we going to use? F is equal to mv squared over r. Good. So F will be mass is, velocity is 200 squared. Then you carefully put in everything. So we can go on. This will cancel this. So that 100 times 200 times another 200, divide it by 15. Your answer will be 2.67 times 10 raised to power 5 newtons. Remember to put the unit. Question number 8. A body is rotating in a circular circle of radius 2.5 meters with an angular speed of 5 rad per second. Calculate the magnitude of the radial acceleration of the body. Please, this word is still the acceleration A. I brought out this particular one. It's from JAMB past question, so that once you see it, you will not be confused. You're looking for the acceleration. Some students will ask in class, we were not taught that, but please note that it is still the centripetal acceleration that we are looking for. Solution given, let's identify. R is 2.5 meters. Speed, this is angular speed. Please don't mix it up. Omega is angular speed. V is the linear speed. Angular speed in rad per seconds is given as 5. Then we are looking for A. Okay? Using which formula are we going to use? Remember that acceleration, centripetal acceleration, this time around radial acceleration, v squared over r. From this, we are going to derive another formula of v squared over r. Remember that v is equal to r omega. So instead of v, I've written r omega. Then you square it all over, bring back the r. This side, v is equal to r omega. So I squared it, and one r inside will cancel one r, so that a will be v squared over r, which is equal to r omega. Please, omega squared. Please note this second formula for centripetal acceleration. Very, very important. You can see it as a is equal to omega squared r is still correct. Let's put the parameters 5 squared times what's r? 2.5 meters. That will give us the final answer as 25 times 2.5. We have 62.50 meter per second squared. So that's our answer. The answer is 62.50 meter per second squared. Question 9. A particle in a circular motion performs 30 oscillations in 6 seconds. Its angular velocity is. Solution. Please note all the new formulas in this video. Please note it. Now we have number of oscillations n, giving number of oscillations as 30. Then time is given as 6 seconds. We are looking for angular velocity. Now, only 2 things are given. How will you solve this kind of problem? Remember that frequency, I'm giving a new formula now. Frequency F is equal to number of oscillations over time. Frequency is number of oscillations n, and we have 30 oscillations all over the time, which is 6 seconds. So let's get the frequency first. That will give us 30 over 6, which is 5 Hz. Now that you have gotten the frequency, the next thing to do is to note using, there is another formula for angular velocity. Angular velocity is equal to 2 pi f. Now let me list all the formulas for angular velocity. You can find it using angular distance all over time. It depends on what you are given. If v is given and r is given, you can use this relationship. Please also note that angular velocity is 2 pi f. There is what is called period. Period is equal to 1 over the frequency. This is formula 1. This is formula 2. This one is number 3. The fourth one that I want you to note is angular velocity can also be 2 pi over t, because there is a relationship between period and frequency. Please note all these formulas. An excellent student is a student that knows beyond what the teacher taught in class. And these are the things that will keep you ahead. Not just only the formulas you know in class, but formulas from past questions. WAEC past question, JAMB past question, IGCSE past question, A-level past questions. These are things that will keep you ahead of others. Now that you have taken note of all the formulas, the one we are going to use is that angular velocity is equal to 2 pi f, which is 2 pi times the frequency 5. This one is from WAEC past question. So use it and prepare for WAEC CBT that will be starting this year, next year, 2026. So our final answer will be 10 pi rad per seconds. Let's look at this from the past question. A force F is required to keep a 5 kg mass moving around the circle of radius 3.5 at a speed of 7 meters per second. What is the speed if the force is tripled? We are comparing the speed when the force is increased. What will happen to the speed? Okay. Solution. Let's write out everything. The first force, given the first force F, the first force F1 is F. The mass M is 5 kg. The radius R is 3.5 meters. The velocity V for the first force is 7 meters per second. So if the force F1 is now increased to 3F, is tripled, that's 3F, what will be the new velocity? You know that the new, if F1 is equal to 3 is increased, so what will be the new velocity? So what we are looking for now, F2 if the force is increased, that means that F2 is equal to 3F1, 3 times the first force. And remember that F2 is equal to mv2 squared all over R. So let's compare these two parts. Let's compare it. So we have 3. What's F1? F1 will have the mass. It will have the first velocity squared all over the radius. Then the second body still have the same mass. V2 that we are looking for squared all over R. So if we go ahead and solve, the radius and the radius, they are equal, they will cancel. The mass and the mass will cancel. So the new velocity that we are looking for, V2 squared, will be 3V1 squared. That will be 3 times, what's V1 is 7 times 7, which will give us 147. So V2 squared is equal to 147. Then V2 will be square root of 147. And that will give us 12.1. You put the formula meter per seconds. Remember to subscribe, like and share this video. I hope you enjoyed the video. Please remember to subscribe, like and share it. See you in the next class.